All right, and this really was the main point. We have two theorems about division, but we're really looking at this factor theorem. So what the remainder theorem says is that if you have some division that you're doing, right? I'm dividing a polynomial by some hopefully linear piece here, linear binomial. The remainder is always going to be whatever f of a is. So I could plug in a into the function and it'll tell me what the remainder is. That's nice to know, but it really helps us because we look at this one and we say, all right, well, not only does it tell us what the remainder is, but if that remainder is 0, we know that we have a factor. This is the big piece. So x minus a is a factor if and only if, that's what that double FF means, if and only if, when I plug in a, I get 0 for my answer of f of a. Okay, it means the remainder is 0, means it was a perfect factor, it divided nice, it will divide nice and evenly. So the factor theorem is really the big piece that we want. All right, and this one just says, check if we have a factor, check if x plus 4 is a factor, and that's easy enough to do because we're going to take the 0, which is -4, plug it into everywhere we see an x, right, and just determine if it's 0. So when I plug in -4, I get -4 to the third. I get 7 times -4 squared, and then 8 times -4, and then -16. Plug all that in the calculator. We do get 0. So that means, yes, this is a factor. I'll put here equals 0. Yes, x plus 4 is a factor because when I plug in the 0, -4, I do end up with 0 as my answer for f of x. Okay, for f of -4. That's just a quick check. And then sometimes we're asked, check if it's a factor. And then if it is a factor, go and factor the whole thing out now that you know what one of the factors are. So we can use division for that. Let's see. Actually, I'm going to go back and just do it here. So if I were to actually divide through, let's go here. So we verified we did that. Now we're actually going to divide. Take this polynomial and divide it by x plus 4. We can do it with synthetic division. We can do it with long division. So for long division, we're just going to set it up like we would, in elementary. I have my polynomial. I'm dividing it by x plus 4. So I'll set up my little long division here. I have x cubed. I have 7x squared, and 8x, and then a -16. We already know the remainder is supposed to be 0 when we do this, so that's kind of a hint to us that when we divide out, if we don't get remainder 0 and we get some other piece, something went wrong. So here we have our question that we're always asking is, well, what do I need to multiply x by? Right? What do I need to multiply x by to get x to the third? Right? Well, I can multiply it by x cubed. I'm sorry. I can multiply by x squared because x squared times x does give me x to the third. Right? But of course I have to use distributive property. I can't just multiply by one of the terms. So I'm going to multiply x squared times 4 and I get plus, there we go, 4x squared. So our question is just how do I get this first term? But when we distribute, we're going to get more terms, which is fine. And then we subtract. And I like to say, just change all your signs. Your signs are all positive, so change them to subtraction. Let me do it in a different color here. Right? Change this to a minus, change this to a minus, right? Because when we're doing long division, we do our multiplying, but we subtract away that factor that we came out with. We subtract away this piece. And then x cubed and x cubed should cancel out. If they don't, go back, change up something went wrong. And then 7 minus 4 gives me 3x squared. I'm going to drop down everything else and repeat the process. So I have an 8x that I'm dropping down and a -16 that I'm dropping down. Repeat the process, right? I say, all right, what do I need to multiply x by in order to get 3x squared? Well, I'm going to multiply it by 3x. Right? And that'll give me, when I multiply, 3x times x gives me 3x squared, which I wanted. And then 3x times 4 gives me 12x. And again, change all your signs, right? Because we're subtracting away what we found. So subtract 3x squared, subtract 12x. I end up with my 3x squareds canceling, and then 8 minus 12 gives me negative 4x minus 16. And then again, repeat the process. What do I need to multiply x by to get negative 4x? Right, I have x here. What do I have to multiply it by to get negative 4x? Well, just negative 4. And then I end up with, when I multiply negative 4 times x is negative 4x. Hopefully you can still see what I have. And then negative 4 times 4 is negative 16. We do have to remember to subtract everything, right? So that means change all my signs. Negative turns to positive, negative turns to positive, and I actually end up with the remainder 0, which we knew it should be. So I'll put here remainder equals 0. Right. Not always going to happen that we get remainder 0, but because we checked and verified it was a factor, we get remainder 0 because this is a factor. So when I say I'm dividing those, I say my answer was x squared, whatever I had here as my quotient, right? X squared plus 3x minus 4. Right, so I verified, I divided. Sometimes you're only asked to do one, sometimes you're asked to do everything. Sometimes you're asked to even take your original polynomial, and now that we know that x plus 4 is a factor, factor the rest of it. So we could say, oh, well, because I know that x plus 4 is a factor, if I wanted to factor it, right, normally we don't really know how to factor anything like this unless factor by grouping works, and it doesn't for this, but now we know how to factor using synthetic or long division. So I'm going to write the problem here. Because I was able to factor out x plus 4, I know that x plus 4 is a factor, and I know that x squared plus 3x, oops, that should be an x squared, plus 3x minus 4 is a factor. But of course, this is not factor completely, right? We got to still use x method to factor this. So if we were asked to factor completely, we could say, oh, x method says I need a number that multiplies a negative 4 and adds to 3. That's going to be positive 4 and negative 1. And then, of course, bring down the factor that we already had. So that means this guy actually factors to x plus 4 squared times x minus 1. So that's like maybe 3 things we could be asked to do. We could be asked to just verify. Boom, plug it in. We found that it was 0. We could be asked to just divide. Do your long division, divide through, and we get our answer. Our quotient is x squared plus 3x minus 4. Or we could be asked to take a next step and say, well, you know what? Factor this guy. Now that you know what one of the factors are, go ahead and factor completely. All right, so if we're asked to factor completely, we take the one factor that we know, take that quotient that was left over, and then factor as much as you can from there. All right, so hopefully that makes sense with the division. We'll get a little bit more practice in the next coming chapters, or sections, I should say. And then I did want to show synthetic division real quick here. Synthetic division just goes so much faster, but you know, it's kind of up to you, whichever one kind of works the best. So let's just say again, we're not verifying, we're just dividing. So we have x cubed plus 7x squared plus 8x minus 16. We're trying to divide that again by x plus 4. If I'm asked to use a certain type of division, long division or synthetic, then I go through. Long division, we just saw the example, but synthetic, I'm looking at the 0 of the divisor, right? Here's my divisor, x plus 4. What is the 0 of this? It's negative 4, right? The number that I could plug into x and get 0 would be negative 4. So I take the 0 of the divisor, and that's what I'm using in synthetic division. And then I just write all my coefficients. I have a 1x cubed, I have a 7x squared, I have an 8x, and I have a negative 16. So 1, 7, 8, negative 16. And remember, if you have any exponent that's missing, right now it's perfect. I have x cubed, I have x squared, I have x1, I have x0. If I have any x that's missing in the middle, between, let's say, x cubed to x nothing, I need to put a placeholder. I need to put a 0 there. synthetic division will not give you the right answer if you forget to put placers in there. Okay, so example, let's say I was dividing, I don't know, x squared minus 4 by something. It doesn't even matter what I'm dividing it by. So if I look at this one, there's an x that's missing, right? I have x squared and I jump all the way down to x to the nothing. So I would have to have put a 0 placer. We just put 0 in place of x, right? My x term. So that's if there's anything missing. Synthetic division, we do the same steps. We say step 1, drop down. So I'm going to drop down that coefficient. Step 2, do our multiplying, just like we would with long division. I'm going to multiply -4, put here, step 2, -4 times whatever's down here times 1 gives me -4. Step 3 is write that answer above the line. So step 1, drop down. Step 2, multiply below the line. Step 3, put your answer to that multiplication above the line. And then keep going. Step 1 again, drop down. 3 and -4, 7 and -4 make 3. I do my second step, which is multiply, and put that answer here. -4 times 3 is -12. I put my answer here. And then again, I do the same steps. Drop down. 8 and -12 give me -4. Second step is multiply. -4 and -4 give me +16. I put the answer here. And then one last time, I repeat the process. Drop down. -16 and +16 is 0, but there's nothing more to do, right? I don't need to multiply here and keep going because there's no more to keep going. So we did get remainder. This last part is always the remainder. Whatever the remainder is supposed to be, that'll be here as your last term. This is our remainder, and this is the coefficient to our answer. Coefficients to our answer. So we started out with x cubed. We divided out, so we're going to end up with 1x squared. It's always 1 less 1x squared plus 3x minus 4 is our answer. Remainder 0, so I don't need to write that. And we know from doing long division that this was our answer before, but this is using synthetic, another way to kind of get your answer. All right, I hope that helps. Of course, ask questions because I won't see you guys on Wednesday for math lessons. I just wanted to give you guys another kind of video, not another, but another chance at looking at what we did in class so that you can kind of stop and pause it if you need to see the steps. Reach out if you have any questions.